Another technique employed in solving trig equations is by something called, it might sound familiar, factoring. So I boxed that word in example 6, but in example 6a, you can see that now we have a mix of cosine and sine, and we have a total of 2 terms. In both terms, we notice there's a sine of theta. So that's going to be our GCF that we pull out. We take out the sine of theta, we're left with 2 cosine of theta plus 1. And if you remember solving by factoring, we set each one of these factors equal to 0 to solve. In the first one, we are going to think about, well, what angle measures between 0 and 2 pi would get me sine of 0. So the first one I can think of is on the unit circle. At 0, y is equal to 0, so therefore sine is equal to 0. My first angle measure is 0. 0 is inclusive in the values that are allowed in the range. And then the next value I can think of is pi. At pi, sine is also 0 because y is 0. And then if we do another half a revolution of the circle, we get to 2 pi. However, 2 pi is not part of my range, so I would not include that. So therefore, these are 2 answers from the first factor. Now I'm going to do the second factor. If I isolate cosine of theta, I get -1/2. So now I'm thinking of what reference angle on the unit circle, if any, gives me -1/2, and that is pi over 3. So cosine at pi over 3 gets me 1/2. However, because it's negative, I want to think of pi over 3 in the second quadrant and in the third quadrant. So that leads me to conclude in the third quadrant, that is second quadrant, that is 2 pi over 3. And then in the third quadrant, that's 4 pi over 3. So all 4 of these answers that I boxed are solutions, which means that if I plugged any one of these 4 angles back into the original equation, it should give me a value of 0 if I simplified it further. On B, what you'll notice is that you have a square term followed by a single term of that something that we don't know. So you almost want to think about it as sine is x. So if you let x equal sine of theta. If you replace x with sine with x, you have x squared minus 2x minus 3. Oh, that should look like a trinomial. So from there, we can factor further. That's x minus 3, x plus 1 equals 0. If I were to solve this, I would set x equal to 3 and x equals -1. However, x isn't what I'm trying to solve for. I'm trying to solve for theta. So what I do is I had let x be equal to sine of theta at the beginning. I'm going to resubstitute sine of theta back in for x on both of these equations. And when I think about this, sine of theta equals 3. Is there ever a time when sine of theta is equal to 3? Well, we can think of our periodic function, the hill, the valley, where the max that a sine function achieves is +1, and then -1 as the minimum. So it can never achieve a value of 3 up here anywhere along the sine function. So therefore, this is undefined, or it does not exist. Sine of theta equals -1. We want to think of all values between 0 and 2 pi where sine of theta or y is equal to -1. And that occurs at 3 pi over 2. So theta equals 3 pi over 2. That's the only solution to B's question.